All right, here's the video guide for lesson 414. What about other right triangles? That's the title of it, because we're going to focus on what about some of the right triangles that haven't met our parameters of our trig table? What if it's a degree that we don't know? How are we going to do that? All right, the other thing that this lesson focuses on is using those complementary angles. Okay, if I use 22, what's my rise, what's my run? If I use its complement, 68, does my rise and run change? And we saw that a little bit with those complementary reciprocal problems. Okay, so a lot of good stuff in here, and I think it's a good lesson that you're going to be able to work through without a ton of assistance, but I'm going to give you some hints through this video guide right here. Okay, first one here is this Leaning Tower of Pisa problem, okay, and it says that if the angle is less than 83 degrees, that the tower may crumble, may fall to the ground, okay, and so what we have is actually a slope triangle here. We have a rise of 50, a run of 5. We can find the slope ratio of that tower and make sure we reduce it down so it looks like something that's probably on our trig table. Okay, now that we can use this trig table in the second part too to determine the angle at which the Leaning Tower of Pisa is slanting, and then we can tell, okay, is it above that 83 degrees or below that 83 degrees? Because if it's less than 83 degrees, say the angle is 65 degrees, then it's probably going to crumble any day now. Okay, so there is some hints on that first one. If you have questions on that, always let me know, because anytime there's word problems, I know that can get tricky. Here we have kind of problems that we've seen somewhat before. Okay, so it does say that if you need to help orient this, you can kind of turn your computer a little bit so it looks more like a slope triangle. And then what we're going to do is we're going to solve for theta, that Greek letter theta, which means the angle here. And then we can also solve for W. Now there's different ways to solve for W. You could use the 79, or you could use the other theta value. But remember, when you find theta, that does change what your rise is and what your run is. And that's kind of what this lesson starts to hint at more and more. Same kind of problem, all right? You can find theta and you can find Z, and you can either use the 22 to find Z, or you could use the theta that you'll find to find Z. And it's all just going to keep being slope ratios, and you can keep using your trig table as a reference here. We should have all of these in, 22 and whatever the theta is. Here's another one just like that one. You can find theta. You can use the 18 to find x. You can use the theta to find x. This again can be on your trig table. We should have 18 and we should have its complement. Here's kind of that question that's going to point out, okay, what can we use? Or when we use what angle, is it going to be my change of y, or is it going to be my change of x? And so this is the first one we'll talk about here. Tina declares, hey, we can rotate this triangle so that the 18 becomes the slope angle, and that means your change of y would be 4. Does that make sense? Would her method work? If you rotate this down, 18 becomes your slope angle, then 4 would have to be your change in y. Mei Ling says that she sees it different. It says that I can tell the change in y is 4 without even moving this triangle. And then you can say, okay, I think I can see that. How is she seeing that? How can she make that judgment call that that's my change in y? And explain how you see it. So here we have Eddie, who's changing the viewpoint of it a little bit, saying that we could use the 72-degree angle, which would be right up here, saying that then our slope angle would be 72 up here, and that means the change of x would then be 4. So then what is he talking about? And discuss with, if you're working in a small group online, or if you're working at home, you don't have to discuss this with anybody, but just think about this. Explain in words why that 4 now becomes the change in x, where previously 4 would have been the change in y, according to Tina and Mei Ling. Okay, when we move on from here, now we can kind of use this idea of, okay, what's my change in y, what's my change in x? And so we want to write the slope ratio for 32 degrees. So if the slope angle is 32, what's the slope ratio? Remember that it's always the change, when we write it in math notes, it's always the change in y over the, I should put that in parentheses. Sorry, wasted time here. Change in y divided by the change in x, which means just rise over run. So then what's the slope ratio if you use the 58-degree angle? How is it different? That's kind of the idea of complementary reciprocal we talked about. Now here is this idea of using a scientific calculator to figure out slope ratios without necessarily using our trig table or needing an e-tool. And so it's an interesting thing. And so what we have here is read these problems really closely. So there's a button that will give you slope ratio when the slope angle is entered. So in part A, you calculated the slope ratio to be 0.652, use the tan button on your calculator, okay? And I'm going to bring up a calculator so you can see it. There's this tan button right here. And every calculator looks different. And if you use your phone or everything looks different, but look for this tan button here. And then do the tangent of 32. So I'm going to do the tangent of 32 degrees. And I get 0.625 when I round it, which was the slope angle, the approximate slope angle we got when we did it before. And so then when we do the 58 degrees, that's just going back in, you do tangent of 58 degrees and you get 1.600, which was what we should get in the previous slide. So this tan button is really, if we have the degree, we can find slope ratio by using tan or tangent. And then here we have the ratio in the right triangle that we've been studying is referred to the tangent ratio, that change in y divided by the change in x of a certain given slope angle. And like it says, like I was showing, it does in your calculator, written as tangent of 32 degrees. And so what we have then, too, at the bottom, it says read more about this tangent ratio in the ebook. So if you want to, you can go to the ebook and you go to the bottom where it says math notes, and it'll tell you more about how this came about and how it relates to what we've been doing. Some good stuff in there if you want to hop over and read that. All right, now we're going to use that tangent ratio to help solve for missing side lengths. So you can do the tangent of 14, because that's the slope ratio, set equal to the ratio of the triangle they're giving you. And so in this problem, it would be the tangent of 38, similar to like what you'll see in the example problem, or example in the directions here. Okay, the tangent of 38 equal to the rise over the run of 38. So if I'm using 38, the change in y is really this value here, and the change in x is this value here, so that makes that, I gotta get back in here, equals x divided by 8. And you could see this as the tangent of 38 over 1, and you could cross multiply here. You could calculate the tangent of 38, which I will do here, if I haven't already. So the tangent of 38, and you get 0.781, and so you could put this as 0.781 over 1 set equal to x over 8. There's a lot of different ways to do this. Okay, now if you go this route, because this is my favorite route here, if you go this route where you leave it as tangent, it looks funny, but we can do this. You can do 1 times x, that gives you x. 8 times the tangent of 38, what that looks like would be 8 times the tangent of 38, which you could put into a calculator. You can do 8 times the tangent of 38 in a calculator by just doing 8 times the tangent of 38. And I like this method more because it gives you a more accurate answer than if you round. So either way does work. If you want to find the slope ratio by using tangent first, set it up as a ratio and solve, or keep tangent as tangent. Like I said, I prefer to see tangent as tangent, and that's what I'm going to work with when you see me in class. Same kind of thing for this problem. Okay, tangent of 79. Okay, what's the rise then? What's the run? And you can set it up like I set up the last one. You have one more like that with 45. You might be able to figure out what x is without doing that, but let's make sure if you check with tangent that you get the right answer. And then we have our learning log just asking us a couple questions. Make sure we know that you can answer the question about how you can find the slope ratio using a calculator, how do we set up a tangent ratio equation, and so on and so forth. If you have questions through this one, the video got a little long, but hopefully it was helpful with some of those hints throughout the way and how to set up problems. But if you have questions, always email me, show up to the synchronous sessions, and be sure that we are understanding these lessons so we're ready to move forward.